Hey everybody, in this video we are going to see how you can do and build a semantic text similarity engine using Java or Kotlin. I'm going to do this in Kotlin using Ktor, but you can do it in equivalent steps using Java and Spring Boot or Micronaut or whatever server you like. The basic problem that we are trying to solve here is that I have a very nice pre-trained semantic text similarity model available on Hugging Face that I'm very easily able to deploy using Python. But when it comes to deploying it using Java, that too on CPU, I'm struggling a problem that model is not easily available and I don't know how to do it. So in this video, if you're the one who's facing these problems, stay tuned. Let's put on some music and solve this problem. So let's start the music. Okay, so I'm gonna open IntelliJ. First, we'll quickly spin up a REST API server. So we'll call it, let's say, new project. We'll select Ktor here. We'll say STS Ktor example. So STS is semantic text similarity. Save it in personal. I'll just do it github.kr shubham. And we'll go next. Okay, I will add a couple of plugins. So we'll add routing is something that we'll add. We'll add course is something that we want to add for local testing if we are building a UI. Let's add content negotiation and let's add Jackson. Apart from that, I don't think we need anything else. Okay, right? So let's create it. So while it is creating, wait, where did it go? Yeah, here's the window. I'll just pop it up here. Okay, so let's take a look at the folder structure generated by IntelliJ. So application.kt is here. We have the server running on localhost 8080. So while this happens, I'll just quickly go to Google Chrome. I will go to my favorite model that I'm using, which is where is AI/UAE large v1. So UAE is Universal Angle Embedding and not United Arab Emirates. So this is the model here and has a pretty decent score on the MTEB leaderboard, and it even had state-of-the-art score at once. Now it's again dethroned by some of the models. We know how AI models come so quickly every week. So there are a lot of examples of doing this in Python. Very easy using sentence transformers or their own Angle EMB library. But we want to do this using in Java using something called as deep Java library, right? So this is what we are going to use. So deep Java library. Okay, all right. So let's see where IntelliJ is. Let's move this here on the screen. All right. So let's just run this and see, and let's go to configure routing and see. Okay, so there is one route. So if we test it out quickly, we'll go to localhost 8080 / and we'll see hello world here. So our server is up and running. Let's quickly go and create a route. We'll call it get/matches, and this route takes a query parameter called query. So we'll just do call.request.query parameters query, and we will do let's just quickly test this. So I'm just gonna rerun the server. Okay, so it's running localhost 8080 / matches query hello cat sat on the mat. So this is working so far. Everything is good. Wait, let's go back. Okay, all right. No, I don't want to zoom on the image. Okay, so the next part is to get this semantic text similarity engine working. Okay, so for this, we're going to take a look at some dependencies. So we're going to add some dependencies to our project. So let me just go to Maven repo and download these dependencies. So we're going to go to ai.djl, go to API, we'll go to PyTorch, we'll do Hugging Face, and we'll do Model Zoo. So we'll add the 0.270 version, which is latest at the time I'm recording this video. So let's add a couple of implementations. So we'll add AI.djl API. We'll add PyTorch engine. So this will be, so let's quickly add all the dependencies. So we have PyTorch engine added. We'll add the Hugging Face tokenizers dependencies that we have. And yeah, And once this is done, the last dependency that we need to add is DJL model zoo. Come on. Okay. So we will add implementation here. We will remove these things and we'll just click on the refresh button. All right. So it's done. It's like, so let's see if we have the criteria object available. It's not yet available because so this is Codium running. So I don't see IntelliJ. So let's see val criteria equal to criteria dot. Let's try and import this. Yep. Okay. So this criteria class is coming from AIDGL repository, which is fine. So we have this working. Now, we'll go to deep Java libraries docs. So use Hugging Face model. Okay. We'll use the link that is within it. So they have this very nice Python utility which can convert a model, which can import a model from the Hugging Face list of models that we have. We can put it in a resources folder and then use it as a local model. While inferencing, we can then deploy it in a Docker image or package it with our jar and then deploy it in a Docker container or in Kubernetes and so on. So productionizing it becomes very easy. And that's the main motivation why I'm doing this video. So let's see. So we'll have to go to their GitHub. So DJL GitHub. We will clone this. So let me just go to the terminal here itself. So we'll just do a git clone. Not here in this, but okay, let's go to stsk, for example. Let's create a new terminal. We'll just go to cd, not cd, but go back and do a git clone. So DJL already exists because I've already done it. So I'll go here in this, or let me do one thing. I'll just go back. I'll redo it because there are some important things that we'll discover in the later parts of the video. So let's quickly do a git clone, git at GitHub deep Java library. So shouldn't take a very long time. And while it does the clone part, we have to run this Python script. But before, we have to install all the requirements and then run this model zoo importer py. Give it the model name. So here we'll give where is AI/UAE large v1. So let's go back. It's done. Let's go to cd DJL. Let's do one thing. Open this project inside code. Okay. So inside extensions, we have tokenizers, src main, Python is where we have our all the files. So we have this model zoo importer file. Okay. So let's open a terminal here. Okay, and we'll go to cd extensions. We'll go to tokenizers, src main, Python. We're here. So we'll just we'll create a virtual env, Python 3.11, and I'm going to do a source env bin activate the virtual environment. And then what we'll do is we'll do Python, not Python, we'll do pip install -al requirements.txt. Okay, while this happens, let's go back to so once we are done with this, it should technically generate a zip file of the model like this. And then we should be able to load it like this and be able to do stuff. Okay. Let's define a couple of questions here, or a couple of sentences that we want to do. So, well, sentence is equal to list of the king can. So let's take some sentences from chess. So the king can move one square in any direction. The queen can move any number of squares in any direction. The pawn can move one direction, can move 1/2 steps initially, or I should write up to 2 steps initially, and can capture diagonally, yeah. Okay, and then we'll add a completely unrelated sentence. Okay, let's us use AI to autocomplete this. The pawn can move the enemy piece away. First move. Okay. So the rat is digging in the ground. Okay. And my name is Shubham. Okay. So while this is done, let's go back here. So this is done. Dependencies are installed now. We will do python-m, not Python model zoo importer -m. We'll just copy the name of the model from here. So we have copy this, and we have it here. We'll paste it here, and then let's run this. So it should be able to do this. Let's see. So it says model not found, namespace limit 1, says model not unsupported model architecture birth model. Let's just search for this string. So unsupported model architecture is here. We'll do one thing here. A quick solution for this is, if model tags does not have sentence similarity, we will copy this line, paste it here, and we'll just do unsupported model architecture. Okay. So we'll just skip all this code and let it run. So let's. Okay, I think it's still not run because it would have created a models.json here. Oh no. Okay, so it's working on it. So it says saving ThoughtScript model UAE large v1.pt, verifying ThoughtScript model, and Hugging Face converter.save. So it did not work here. I'm deleting the models.json file because it did not work. And let's go to Hugging Face models. There is a Hugging Face converter. So we have here save to model zoo. Okay. So here we have, so here this function call has 1, 2, 3, 4, 5 arguments, but we go to the definition, it has 1, 2, 3, 4, 5, 6 arguments. So we'll just go to the place where it's being called, which is here, and we'll add an engine after this. Engine is PyTorch. Okay. Let's just quickly check. So output there and then engine. Okay. So if we do this with the models.json deleted important, let's run this now. I think we should raise a pull request so that this is rectified in the main repository itself, main code. Alright, we are verifying ThoughtScript model, saving DGL model as zip. Let's see. We have a folder model create. Oh wow. So we have this model NLP text embedding AI DGL Hugging Face PyTorch. Where is AI UL 001 UL large v1 created. Okay. So now what we can do is we can go here. We can do cp-a /djl/extensions tokenizers src main python model to /src main resources. Okay, so let's see. So inside resources we have this models folder now. Okay, so what we are going to do here is we'll do application. Okay, so we now have to get the file, get the path basically, and load it. So we will do here val path equal to application dot class dot java dot class loader dot get resource. So let's copy this path, copy let's copy the path for the zip files. We'll do copy path reference from source root, paste here. Okay, and we will build the criteria here. So val criteria equal to criteria dot builder as shown on the website. So let's copy this code here first, and let's add this here. So we'll have to change the types. Okay, let's remove this. We have criteria dot builder dot set types is going to be, so this is going to be string class dot java as the input, and output will be a float array class dot java dot opt model path is going to be paths dot get path dot to URI. Okay, translator factory is going to be a defaulter. We don't need new in Kotlin. We'll just do this. Progress is going to be a progress bar. Don't need new in Kotlin again. So import class progress bar dot build, and then what we can do is we can get a val predictor or val model equal to criteria dot load model, then val predictor equal to model dot new predictor. All right. And then what we're going to do is so we are going to pre-process all the embeddings of these sentences as in a list called embeddings. So we'll do embeddings, or we'll do not sentences dot map index comma string. We'll do predictor dot predict string okay, so what we'll do is we'll keep the val float array or val predict val embedding equal to this, and we can actually just map it, right? We don't need index actually here, so we can just do a map. So we can just do it. So map it to predictor dot predict it, right? So this will become embeddings. So now what we'll do is we'll do embeddings dot, so while replying for the answer we'll do map index, we'll do index comma embedding. So we will do a cosine similarity. Let's create a cosine similarity function here. So private fun cosine similarity float array double, and we'll just let AI write the code. So it's doing it right. Dot product is equal to the product of the indices. Norm of A will be AI into AI. So yeah, okay, modulus. So A square square, and then we do square root. Okay. So looks good. So we will do. So we will return var similarities embedding comma this, and we will return a similarity to index. Okay, we will return this similarity to, so we'll return a pair of similarity dot index, and then sorted by descending it dot first dot take 3 dot take 3 dot map it dot second, and not join to string, but just keep it as a list, and we'll do val closest matches, and we will do a call dot respond text, or we'll just do a call dot respond with the closest matches, right? And let's rerun our service. So stop it and restart it. Let's see how it compiles. We don't have any issues. Let's see if the model, it's able to load the model in one go or not. We have to solve some issues. Alright, so found default engine PyTorch. Okay, looks like it's up. And the moment of truth, so localhost 8080 slash matches query. King is an important piece. So we're getting 051. Okay, so we are getting IT second here. We should get the actual sentences of IT second, correct? Yeah. So rather than the indices, we actually want the sentence. Let's restart it. Restart our server. You see the startup is also pretty quick. So let's refresh this. The king can move, the knight can move in L shape, queen can. So see, the king came on the top. Now I'm gonna say, who is Kumar Shubham? It should. My name is Shubham is the topmost match. Let me say, do you know my name? My name is Shubham is again on the top, the best match string. So we can see that semantic text similarity is working, and my name is Shubham is coming on top for the query, do you know my name? And so this is how you can create a semantic text similarity API using a pre-trained model from Hugging Face. So to summarize this quickly, all we need to do is use the Deep Java library, their Python converter, which is here on the extension tokenizers. We can, again, you can take a look at the Python code inside the model zoo importer, correct the code wherever required. I think if you find an issue, I think we should raise it to the original repository so that it can benefit all the other people. And we'll have a pre-trained model saved. We can push this model to S3, or you can keep it in your repo, whatever you're comfortable with. And this was so easy to it was so easy to spin up a REST API server and thus deploy it as a REST API service. So again, I did not write a service, just put everything in the router. Again, feel free to modify the code, do it in a way, in an extensible way. You can create a service, do dependency injection, and all of the SaaS. But the goal of this video was to get you quickly started with doing deep learning and NLP in Java and Kotlin. I hope this helped. And if you guys really like this video, give this video a thumbs up and subscribe to the channel for more such videos. Until next time, bye.